This is SpaceTime Series 28, Episode 63, for broadcast on the 26th of May, 2025. Coming up on SpaceTime, the universe to end sooner than thought, the weird, wild, wacky gravity of the asteroid Bennu, and India to undertake its first manned spaceflight within 2 years. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims the universe could end in 10 to the power 78 years from now. That's a 1 with 78 zeros behind it, and it is much sooner than previously thought. The findings, reported in the Journal of Cosmology and Astroparticle Physics, are based on the calculations of 3 Dutch scientists looking at so-called Hawking radiation. They calculate that the universe's last stellar remnants will take about 10 to the power of 78 years from now to evaporate, and that's much shorter than the 10 to the power 1,100 years previously postulated. Hawking radiation, proposed by Stephen Hawking back in 1974, is a phenomenon where black holes emit thermal radiation due to quantum effects near the event horizon, the point of no return, beyond which an object falls forever into a black hole singularity. This radiation reduces a black hole's mass, eventually leading to its disappearance. Now, it works like this. Quantum physics predicts that the vacuum of space isn't truly empty, but rather it contains constantly fluctuating pairs of virtual particles and antiparticles that literally pop in and out of existence. Now, near a black hole's event horizon, these virtual particles can be separated by the singularity's intense gravity. If one of these virtual particles falls into the black hole, the other can escape and be observed as radiation, becoming real and effectively evaporating the black hole. The escaping particle carries or radiates away energy, thus reducing the black hole's mass, and the rate of this evaporation would depend on the black hole's mass. Larger black holes have lower Hawking temperatures and evaporate more slowly, while smaller black holes have higher Hawking temperatures and therefore evaporate faster. Now, over time, the continuous emission of Hawking radiation would theoretically lead to the gradual evaporation of the black hole itself. And taking that to its natural conclusion, eventually the black hole's mass will reach zero. It'll no longer exist. Now, the new research by black hole expert Hino Falke, quantum physicist Michael Wondrake, and mathematician Walter van Sulcrum, all from the University of Radboud, is a follow-up to an earlier 2023 paper by the same trio. Now, back in that paper, they showed that not only black holes, but also other objects such as neutron stars can also evaporate through Hawking radiation. Now, after that publication, the authors received heaps of questions from scientists about how long the process would take. And they've now answered that question in this new study. And as we mentioned at the top of the story, the authors have calculated that the end of the universe is about 10 to the power of 78 years away, if only Hawking-like radiation is taken into account. They base this on the time they calculate it would take for a white dwarf star, the most common persistent type of celestial bodies in the universe, to decay through Hawking-like radiation. The problem is previous studies didn't take this into account, putting the lifetime of white dwarfs at 10 to the power of 1,100 years. Now, the researchers calculated that the process of Hawking radiation theoretically also applies to other objects with a gravitational field. The calculations further showed that the evaporation time for an object depends only on its density. To the authors' surprise, neutron stars and stellar mass black holes took the same amount of time to decay, 10 to the power of 67 years. This was unexpected because black holes have stronger gravitational fields than neutron stars, which should cause them to evaporate faster. But the thing is, black holes have no surface, so they reabsorb some of their own radiation, and that inhibits the process. It's a fascinating study, all purely hypothetical of course, but nevertheless fascinating. This is SpaceTime. Still to come, the weird, wild, wacky gravity of the asteroid Bennu, and India to undertake its first manned spaceflight within 2 years. All that and more still to come on SpaceTime. Astronomers have examined the weird Alice in Wonderland-like physics that govern gravity near the surface of the asteroid Bennu. The new findings are based on data gathered by NASA's OSIRIS-REx spacecraft, which undertook a sample return mission to the half-kilometre-wide near-Earth asteroid. The probe was launched back in 2016, arriving at Bennu in 2018. It then spent 2 years studying the carbonaceous Apollo group space rock before swooping down to the surface and grabbing some samples for return to Earth in 2023. During the mission's study of Bennu, scientists examined and mapped its topography, its structure, its composition, and, importantly for this story, its gravitational pull. A report in the journal Nature Astronomy found the asteroid has a mass of 73 billion kilograms. And the authors also found that Bennu exists in a delicate balance between two competing forces, the result of the asteroid's spin. See, Bennu completes a full rotation around its axis once every 4 hours. That's quite fast. The study's lead author Daniel Shears from the University of Colorado Boulder says those forces play an important role in the asteroid's long-term evolution and potential demise. He says when you spin an asteroid up, you create a competition between gravity, that's holding things together, and centrifugal acceleration, which is trying to pull things apart. To study those forces, Shears and colleagues used OSIRIS-REx's navigational instruments to measure the minute tug that the asteroid exerts on the spacecraft. And in the process, they dug up a lot more than they expected. Now, based on the group's calculations, it appears the region around Bennu's equator is trapped within a gravitational feature known as a rotational Roche lobe, and that's something scientists haven't yet clearly observed on an asteroid. Now, the Roche limit is the point at which the gravitational tidal effects of a large body on a smaller one become so powerful as to overcome the smaller body's own internal gravity, causing it to fling apart. And she's found that that's when things get weird with Bennu. So now, if you're standing inside the boundaries of Bennu's Roche lobe and you slipped on, say, banana peel, for example, then not much would happen. You'd be captured by the lobe and fall back onto the surface. But if you were outside the Roche lobe and slipped on that same banana peel, you'd end up rolling towards the equator. And you could theoretically gain enough energy to quite literally roll off the equator and up into orbit and then into outer space. Now, Shears admits it all sounds like the sort of environment Lewis Carroll would have appreciated. But it does matter in real life, especially for the lifespan of Bennu. See, that's because radiation from the sun is causing Bennu to spin faster and faster over time. And as the asteroid's rotation builds up speed, its Roche limit might also be shrinking, along with the forces that are holding the whole thing together. And as the Roche lobe narrows further around the equator, it becomes easier for the asteroid to lose material. Shree says that so far that material's been trapped by gravity, but at some point, if the asteroid keeps spinning faster, then you would wind up falling off the cliff. In other words, Bennu could well be in the process of spinning itself into pieces. And Shree says that's important because Bennu is one of those asteroids which could one day impact the Earth.
The main role of the University of Colorado on the OSIRIS-REx mission is in the radio science experiment. When we send a spacecraft out to this asteroid, millions, billions of kilometers away from the Earth, the only way we can command it, control it, see what it's doing is by sending radio waves out to the spacecraft. The main result from radio science is actually to measure the mass and the gravity field of this asteroid. Pristine material from the very dawn of the solar system. Bennu has a non-negligible probability of impacting the Earth a few hundred years in the future. We take our very precise measurement to determine its location accurately enough so we can say, oh, okay, it's going to miss the Earth by a far distance in the future. If in fact that's not the case, then we need to start thinking about, well, how would we actually push this asteroid out of the way? You need time and you need to understand the properties of the asteroid.
That's Daniel Shrees from the University of Colorado Boulder. And this is SpaceTime. Still to come, India to undertake its first manned spaceflight within 2 years. And later in the science report, archaeologists excavating the ancient Iraqi city of Nineveh have discovered the royal palace's throne room. All that and more still to come on SpaceTime. Today's episode of SpaceTime is brought to you by Insta360, the game changer in 360-degree camera technology. Now, if you've ever wondered how some creators manage to capture those jaw-dropping third-person shots, you know, the ones that look like they've been taken by a drone following you, well, that's probably Insta360 magic. Their latest model, the X5, isn't just another action cam. It's a fully blown immersive video powerhouse, putting a production studio in the palm of your hand. The X5 captures 8K 360-degree video, meaning you're recording literally everything around you at once, forward, backwards and sideways. And here's the kicker, you don't even have to aim. Just press record and enjoy the moment, and then reframe your shot after the fact with the Insta360 app's AI-powered tools. Want to follow your movement, lock onto a subject, or create stunning 360-degree pans? Well, now that's just a few taps away. And for those epic how on earth do you film that shots, the invisible selfie stick's your secret weapon. It vanishes from the footage, giving you that cinematic floating camera look, perfect for POVs, adventure reels, or even space-themed explorations right here on Earth. Plus, with a larger sensor and a dedicated night mode, your low-life footage doesn't just survive, it thrives. Think clear skies, dazzling cityscapes, or even a starlit time-lapse. This is hands down the best 360-degree image quality Insta360 has delivered yet. So, if you're a creator, explorer, or just someone who loves telling stories in a bold new creative way, the X5 is ready for launch. To bag a free 114cm invisible selfie stick worth $24.99 US with your Insta360 X5 standard package purchase, head to storeinsta360.com and use the promo code SpaceTime. But be quick, it's available for the first 30 standard package purchases only. And for more information, be sure to check out the links in our show notes. Head to storeinsta360.com and use the promo code SpaceTime. And now, it's back to our show. The Indian Space Research Organisation ISRO says it'll attempt to launch its first manned space mission in early 2027. The historic flight will follow an unmanned test flight of the nation's Gaganyaan spacecraft later this year. The 5.3-ton capsule is designed to carry a crew of 3 into low Earth orbit. The spacecraft will be sent into orbit using an updated version of the 59-metre-tall GSLV Mark III rocket, GSLV standing for Geosynchronous Satellite Launch Vehicle, although these days it's also being known as Launch Vehicle Mark III, or LVM-3. So far, 4 Indian Air Force pilots have been selected for the flight, and they've already undertaken their cosmonaut training in Russia and are now undergoing further mission specialist training back in India. And the Indian Navy's also been rehearsing, conducting sea recovery trials for the mission, with more simulations planned prior to the flight. Meanwhile, an Indian rocket carrying a new Earth observation satellite has failed to reach orbit. The PSLV C-61 launch vehicle blasted off from the Shrikota Space Centre on the Bay of Bengal coast, carrying the EOS-09 spacecraft. ISRO says there was a sudden fall in chamber pressure during the third stage rocket burn, preventing the payload from reaching orbit. An investigation is now underway. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has found that herpes simplex 1, the virus responsible for cold sores, may also have a key role to play in the development of Alzheimer's disease. The findings, reported in the British Medical Journal, suggest that treatment with antiviral therapy might be linked to a lower risk of the condition. The authors matched up close to 350,000 pairs of people, one diagnosed with Alzheimer's and the other without. Now, overall, they found the likelihood of an HSV-1 diagnosis was 80% higher among those with Alzheimer's. They also found that people who used antiviral medication after their diagnosis were 17% less likely to develop Alzheimer's compared to those who didn't use the treatments. Additionally, the authors also looked at the role of other herpes viruses and suggest that both HSV-2 and varicella zoster virus infections were also associated with a heightened risk of getting Alzheimer's. Archaeologists excavating a dig site in the ancient Iraqi city of Nineveh have discovered the royal throne room of the North Palace of King Ashurbanipal. The find includes large portions of a monumental stone slab some 5.5 metres long by 3 metres high, weighing around 12 tonnes. It features a carved relief depicting the ruler of the Assyrian Empire from the 7th century BCE, along with 2 important deities and other figures. Shown in the centre of the recently discovered relief is King Ashurbanipal, the last great ruler of the Assyrian Empire. He's flanked by 2 supreme deities, the gods Ashur and Ishtar, the patron goddess of Nineveh. Archaeologists believe the figures suggest that a massive winged sun disk was probably originally mounted above the relief. The ancient city of Nineveh, located near the modern Iraqi city of Mosul, is considered to be one of the most important cities of North Mesopotamia, and under King Sennacherib became the capital of the Assyrian Empire in the late 8th century BCE. A new study has found that native Australian bees living in areas where European honeybees are prevalent wind up having fewer female offspring and a higher death rate in their first years of life. The findings, reported in the Journal of the Frontiers in Bee Science, studied native bees living in bee hotels, wooden boxes designed for native bees to rest and breed in. They looked at 14 sites around Perth, looking at whether their proximity to introduced bees impacted various signs of fitness. The authors say it takes fewer resources to produce male bees compared to female bees, so the change in sex ratio they observed among native bees could be a sign that the natives are struggling to compete for resources, which in turn makes it harder for the next generation to reproduce because there are fewer females in the area. While a source of eternal frustration for those of us fascinated by the wonders of a universe of science fact, for many others, the mysteries of the supernatural retain a sort of magical allure. Now, whether it's the Bermuda Triangle, personality tests, ghost hunting, crop circles, the Loch Ness Monster or Bigfoot, they all have one thing in common. They simply don't live up to the rigours of actual scientific testing. Nevertheless, they all attract passionate supporters. And in fact, even when people know they're not real, they're still often fascinated by the idea. And Tim Mendham from Australian Skeptics says there's a whole range of reasons why this is such a common human quirk.
Various reasons have been suggested. One is that people want our world to be more exciting, more glamorous, more weird, mysterious. So that's one thing, is the excitement level. The other one is the fear level, that the world's a pretty scary place. Things happen to you without any apparent reason. I'd like there to be some more reliable information in the world. And if I don't feel that the world as it is, as I know it, is reliable, I'll tune into something else, which is sort of UFOs exist, or the world is flat, or the stars can decide my future, etc. That's another one, that fear factor. The other one is a conspiracy factor, that anything which is associated with established fact or science or policy must be false, because obviously they're campaigning against us, whether it's big government, big pharma, big science, whatever. Anything they say is inherently false according to some people, and therefore will go to the opposite. If I don't trust the government, therefore something which is anti-government must be true, which is poor logic, but never mind. It's never been a major issue. So the governments are trying to block UFOs. Governments are trying to block this knowledge or that knowledge. Therefore, that knowledge has...
hiding the truth about Bigfoot.
Well, I don't understand that one, actually. I don't know why a government would actually cover up Bigfoot. I thought, tourism, etc., would be a good thing.
It's the latest Animal Planet Bigfoot story that's doing the rounds.
Yeah, it probably is. I mean, the inventiveness of people to find conspiracies is never ending. So there's various reasons why we like pseudoscience. One is fun. It might be a fun thing. Like
it is fun. That's why we cover it on this show, because it is.
That's right. Yeah, there are it's fun elements. It's exciting. It's interesting. It's as interesting as Harry Potter. I don't believe Harry Potter is real. I don't believe the Loch Ness Monster is real. It doesn't stop you enjoying them. But then, it also...
You've been there 3 times. Come on.
I have been there 3 times. Not to Harry Potter, I should say, actually, but the Loch Ness I have been. Yeah, it's great fun. It's a lovely place, too. I recommend it. Nice little restaurants and things. But just by saying it's fun doesn't mean it's true. And if you believe it's true, it can actually start influencing you in what you do in life. Like, astrology is not true. Your listeners always interested in astronomy would probably know that there's nothing in astrology. There's nothing in the flat earth theory as well. Probably nothing in UFOs, UAPs, whatever. No evidence, certainly. But people follow astrology. People definitely follow astrology and use it to make their life decisions. People are interested in UFOs and can use that as part of their philosophy of anti-government everything, and that UFOs are here to save us or destroy us, depending on your point of view. Flat earth is a classic conspiracy theory. They're trying to cover it up. It's one of the silliest conspiracy theories out there. But I mean, there are things which are dangerous to people, and those things that are fun, fine, have fun. But what the skeptics see, unfortunately, is these things extending into other areas. Conspiracy about UFOs might be a conspiracy about health as well. It might be a little lean to the same mindset.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.